Hello, I'm Suyash Vardhan Srivastava, 17 BEC 1230, and today I'll be performing 16-bit QAM quadrature amplitude modulation given to us by Ralph Sir in DCS theory class. So QAM basics basically consists of two carrier signals, C1 and C2, and which differ in phase angle. So we can say that if one is sine, the other one will be cosine carrier. As we can see here, we set the modulation order and get a random data. As we can see, we have set the modulation order to be 16, and we get a random data and store it in a variable x. Now we modulate this data and use the unit average power function to set the output signal to have an average power of 1 watt. So this is a modulated signal with an average power of 1 watt. To confirm that the signal has unit average power, we find its mean. Now we plot this. Now we plot this data using the function scatter plot. So the plot that we get after using scatter plot function in MATLAB is a 16 QAM with the average power of 1 watt. Now we create a binary data sequence. When using binary data inputs, the number of rows in the input must be an integer multiple of number of bits per symbol. So we create a variable data that will have random values. Now we modulate this signal using bit inputs and set it to have unit average power. So this is a transmitted signal with average power of 1 watt, and now we introduce noise to the signal. So we have introduced AWGN noise to the signal, that is additive white Gaussian noise. Now we plot the constellation diagram, that is the output of this noisy signal is called the constellation diagram. So when we run this code, we'll get two plots. First one is a scatter plot, that is the 16 QAM and with the average power of 1 watt. Whereas the second one is a constellation diagram that consists of the noise, that is also a 16 QAM with average power of 1 watt, but this has noise to it. So seeing both these plots, we can conclude that QAM has been implemented successfully.